So now let's take a look at the indefinite integral of a function of the form of b to the x. Now we use the fact that d dx of b to the x equals ln b times b to the x. Now this leads us immediately to what the indefinite integral must be. So for b greater than 0, and obviously not equal to 1, the integral of b to the x dx must be equal to b to the x over ln b plus that constant of integration. Now, I know that because I know that if I integrate this, whatever I get, if I take the derivative, I have to get this thing right back. So, if I take the derivative of b to the x, I get, like I said here, ln b to the x, but I need a b to the x. So because I know that d dx of b to the x equals ln b times b to the x, I know I have to divide this by ln b. So these ln b's that cancel out, and I end up with just b to the x. That's the reason why I divided down here by ln of b. So obviously, if I take the first derivative, d dx of b dx over ln b plus some constant c, I will get that the derivative of b to the x is, again, ln b times b to the x. And of course, I have ln b in the denominator. Those are cancel. And of course, the derivative of c is 0 because it's a constant. So I simply end up with b to the x just like I'm supposed to. So let's go ahead and take a look at a couple of quick examples here. So I want to integrate 3 to the x dx. So I know that if I take the derivative of 3 to the x dx, I'm going to end up with ln 3 to the x dx. So this antiderivative has to be 3 to the x over the natural log of 3, again, plus my constant of integration. Now this one is going to be a little bit trickier because of that 5. Let's go ahead and go about it the way you're probably thinking. Let's just do a straight u substitution. If I let u equal 5x, then du equals 5 dx, which means that du over 5 is equal to dx. So this gives me 1/5 the integral of 3 to the u du. Well, now I know this. I can take the antiderivative because it's actually exactly of this form. This is going to be 1/5 times 3 to the u over ln 3 plus, don't forget my constant of integration. But let's not forget that u is 5x. So this is actually going to give me 1/5 times 3 to the 5x over ln 3 plus that constant of integration. So there's my solution. Now I want to use that same approach here with a u substitution because this is x squared and this is x. So if I let u equal x squared, du is going to be 2x dx. Other than that 2, I'm going to have exactly what I need. So let's let u equal x squared. Then du equals 2x dx. That means du over 2 equals x dx. Now x dx is exactly what I have sitting right here. So that gives me 1/2 times the integral of 3 to the u du. That is going to be 1/2 times 3 to the u over ln 3 plus that constant of integration. And let's not forget that u is x squared. So this actually is going to give me 3 to the x squared over 2 ln 3 plus c. And obviously, because of the properties of exponents or properties of logs, I can write this as ln of 3 squared, which is ln 9. There's a couple different ways I could write this thing, but this is fine, just the way it is.